Hello everyone. Next up we have Mackenzie Jackson, who's going to tell us how the internet is broken.
Hello everyone. Welcome to this session. So my session's title here is The Internet is Broken and How the Modern Supply Chain Created an Insecure World. Light and fluffy talk for this evening, but hopefully we can make it a little bit of fun. Just a little bit about me, if you're wondering where my accent is from. Originally I'm from Aotearoa, which is New Zealand. I live in the Netherlands now. I work for a French company called Get Guardian, and you can find me anywhere on the socials of @AdvocateMac. I'm also the host of the Security Repo podcast. It's my mum's favorite podcast. She recommends everyone listen to it, so feel free to follow. All right. So I want to start this presentation somewhere probably a little bit weird, but I promise it will kind of make sense, maybe. But this here was an advertisement that came out for cigarettes in the 1960s in America from a company called Lucky Strikes. And it was after some research came out that definitively proved that smoking was actually, in fact, bad for you. And so these companies were caught between a tricky situation, because did they then try and improve their product or create something different that wasn't unhealthy for you, or do they simply try and mask that with clever branding? And obviously they picked the latter. And so Lucky Strikes came up with this slogan here saying, "Lucky Strikes, it's toasted." And they did this, well, they came up with all these claims that by toasting the cigarettes it created less throat irritation, that by toasting the cigarettes it helped fight against the cough. And in a way, they were saying that because it's toasted, actually, it's much healthier for you. Now, I know there's a few smokers around here today. Anyone tried untoasted cigarettes? Anyone smoked wet tobacco before? Oh, one guy has. Okay, the first person has put their hand up. But the point is that the product was always toasted, and all the other competitors' products are toasted. They had no difference in what they were doing. They were just using clever words and marketing to try and cover the fact that actually this product wasn't healthy. And they used this a lot, and they used a lot of physicians and doctors to try and come up with this. And everywhere it was saying that it made it less dangerous. But obviously we know that that's all just marketing, and really there wasn't anything to it. So how does this have anything to do with the internet, and why is this to do with the supply chain, and how does all that fit in? Well, my argument today is that the internet is toasted. And in that sense, that we've come up with all these different ways to make us feel better about how ridiculously unsecure, and not just how unsecure it is, but how little control over security we actually often have. So the internet has become toasted. Now, what is an exact example of the internet being toasted? There's one really good one that I like to use, and it's called the cloud. Right? What exactly is the cloud? So the cloud was this term that came up, it was coined, it was created in similar marketing labs as that cigarette commercial saying that it's toasted. And basically is a way of obscuring something so that we didn't actually have to think about what it was that it was doing. So if we use, this example of what exactly is the cloud? Well, it's basically someone else's computer. It's basically offloading a job that we used to do ourselves, or that we had control of, that we don't want to do anymore because it's become too complicated. So we offload it to someone else. And we call it the cloud because we don't actually have to want to think about the fact that all of our data, all of our access, all of our applications, how we build those applications, and everything that has to do with it is all managed by other people, and we don't have a lot of control over that. So I took this example from an FAQ of a question was, how do you store your data? And the actual answer of this company that I won't name was, we securely store our data in the cloud. Now this is the perfect example of a toasted answer, because if we untoast this a little bit, what we get with is that we outsource security to store our data on someone else's computer. Now that doesn't sound very good, because basically what we're saying is that, hey, we don't want to have to deal with that, so we're giving it to someone else, and we're giving all the security that we're claiming to do ourselves, and we're putting it onto them. And so that's really the situation of the internet, of where we've got to. And this has been around for a little bit. This isn't entirely new, but the supply chain and how we build our applications has also now gone into the cloud. I'll use the cloud from now on, but when I'm talking about the cloud, really I'm talking about this offloading into big data services and offloading it into individual systems that we don't have control over. But if we have a brief look at kind of the internet and what happened, what's really interesting is that in its conceptual years, up until about 1990 when it really went mainstream, all of the security protocols, or a lot of the security protocols that we use at the foundations of it, the asymmetric encryption that we have, obviously we've improved on that, but the foundations of that was all created during this period, which is a period that they probably could never have imagined how we actually use it today. And then if we look around 2008, it was when Dell started to try and trademark the term cloud computing. It wasn't the first time that that term had been used, but it was the first time that people really tried to make it into the mainstream. And it's around this time when the internet really started coming out with some very heavy applications. Around about this time, we stopped using the internet as a forward-facing thing. We actually started putting complex applications on there. And so this is when it started getting really scary, is that how are we all storing this data? How are we managing everything? Well, if we create some concept called the cloud, then we can divert people's attention away from the reality of what it is. But I want to get into a little bit more of the nitty-gritty detail of exactly what all this means. And I want to talk about, why does this matter? And this really matters now because of how this has changed the game for attackers, and in particular how it's changed the way that we build our applications and not just host them. So we obviously know about the supply chain. When I talk about the supply chain, a lot of people might think of something more traditional, like the automotive supply chain, where we have raw components, we have assembling lines, we have testing lines, and then we ship out the product. Well, we also have a software supply chain that follows similar rules here. We have our open source and proprietary code. Then we have how we manage and interact with that, our IDEs, our development environments. Then we have testing environments like Circle CI or Jenkins or other CI/CD pipelines. And then we ship our artifacts in a form. Maybe it's in a Docker image or for example. So this is here the software supply chain. But the software supply chain has also ended up in the cloud. So what does that mean? It means that this is all remotely accessible, that we're not controlling all of this data anymore, and we're outsourcing a lot of that security, a lot of that to different individual companies. So this is kind of the situation that we've ended up. Now, you may be wondering, why does this matter? This is a good thing, that having this information in the cloud makes it easier for work, it makes it easier to engage with colleagues. Why is this, from a security point of view, necessarily a bad thing? And the reason is this has really changed the game for attackers. So if we look at economics of the attackers, or hackonomics, these hackers needed to follow certain rules. So when we think about a hacker, we've got to stop thinking about an individual. Perhaps there's some in here, but they're more looking at organizations. So malicious organizations that are targeting people. Now, these organizations have employees. These employees have pay, they have holiday pay, they take sick leave. These are normal organizations. And because of that, just because they're doing nefarious things, doesn't mean that they operate outside the bounds of normal organizations. In the terms that they have risk-reward calculations that they need to do when they're attacking someone. So for example, if they're trying to attack this organization, if this organization isn't very large, it doesn't have a lot of payoff, perhaps that doesn't meet the requirements of the risk-reward that they're looking at, so they might ignore this. And they have to put a lot of energy into doing reconnaissance and actually executing that attack to be able to break into those systems. But now, because our supply chain has really turned into the cloud, and they can target multiple points of our supply chain that is like virtual on the internet in the cloud, well, they can potentially access thousands of these different companies, which means the risk rewards is a lot higher, which means that they're able to do much more sophisticated attacks because we've shifted everything, including our supply chain, up into the cloud. So this is why it really matters. We've changed the game for attackers. They can now invest lots more money into targeting components into targeting systems because we're so reliant and because we can then move into lots of different organizations. We've really expanded the scope. And so this is really part of the reason why it's so dangerous to have clever marketing around what is actually controlling our security and where it actually sits. What is our data actually doing? Because it's not just sitting in the cloud, it exists somewhere in a physical location. So I want to talk a little bit about the supply chain, and I want to talk about how we can attack it, and I'm going to go through concrete examples of where we can attack our supply chain and where it's actually happened, and the methods that those attackers have used. So of course, this graph here comes from Salsa, which is a Google-run foundation that looks at simplifying the supply chain and illustrating different areas of it. So this may look pretty simple. We have a developer, we have a source code, or a source. We go through a build cycle, we have dependencies that relies on, that gets packaged up and shipped out to the consumer. Now every one of these red dots, or these red exclamation points, is where we potentially could target this software supply chain. And what I want to do is I want to look at just 3 of these. So I want to look at, just in the interest of time, how we can attack our source code through the cloud in the digital world, how we can attack the build process when that is in the cloud, and how we can also attack the dependencies that we run on. So that last one there, dependencies, that's where I'm going to start in this. And let's have a look at exactly how attackers can target the dependencies that our software runs on. So just very quickly, what am I talking about when I'm talking about software dependencies? So we all probably know that we have our application, but most of that application, a lot of that application relies on open source packages, open source dependencies that we're going to plug in. But it gets a little bit more complicated than that because the dependencies also have dependencies that they need to run. And then we can go a little bit more complicated. And in fact, we can generally get to about 30 layers deep where we have all these different dependencies, software dependencies, that are dependent on each other. And our application is dependent on them as well. But it gets a little bit more, we're probably familiar with this, but we can also think about third-party services as our dependencies as well. For example, if we're using credit card processing, perhaps we're using Stripe, maybe we have a managed database. So we have all these third-party services that are all dependent on our application. And the problem with how extrapolated this has become on the cloud is that we often have absolutely no visibility of what actually is running our application. And in fact, attackers often know our application better than we do because they know what the components are made up on it. But it gets a little bit more complicated because that was a nice line, but it actually looks a little bit more like this because we have dependencies that are dependent on each other. We have our third-party services that are dependent on open source dependencies that we might be. So the system gets extremely complicated. And if one of these gets turned malicious, so there's a little red dot there. Let's just call this little red box log4j or log4shell, whatever you want to call it. Then what that can do is that can turn a whole bunch of things malicious, including the third-party services that we're using. Now, we may not have chosen to put this dependency in our package. We may have no idea what log4j is or what it does, but because so many different systems are using it, we're actually vulnerable to that as well. And this is where we get to this obfuscated view and where we don't understand what's actually happening in our application, because everything's so interconnected, everything's moved into the cloud, onto the internet, and attackers can find their way into our application through these various means because of how open everything is. And as it's saying here, some people say 85, some people say 90, some people say 95. I chose 95, not for any academic reason, because it was the highest number. But a lot of people say 95% of our code is in our own. And that means that 95% of what makes your application run comes from dependencies, comes from those third-party services, come from the open source tools. And we have this thing that we trust it a lot more than what we do our own. And I can't quite figure this out, but I think a lot of it is that we know what we're doing maybe as developers, as organizations, where we're maybe cutting a little bit of corners. And you kind of assume that no one else is doing that. Everyone else is a perfect developer, but you're a little bit dodgy. But the problem is that everyone's a little bit dodgy, and there's plenty of opportunity for attackers to break into these dependencies. I hate showing this next slide, but it's the perfect slide, so I will show it. But I'm sure we've all seen this meme before, where we have our modern infrastructure, and then everything stacked on, and then we have this one little box down there, which is a project that some random person in Nebraska has been thanklessly maintaining since 2003. And if that falls over, the whole show falls over. But we can actually give that project in there a name. The person that's been thanklessly maintaining that project, or one of them, is a guy named Fashal. Now, we like Fashal. Fashal represents a whole bunch of different people that are maintaining open source projects for the good of the community, often thanklessly. But that doesn't mean that they're faultless. So I'm going to show you the project that Fashal has been managing. It's called UA Parser. And what this does, it's a JavaScript library that has the ability to detect what people are viewing your application on. So what operating system are they viewing it through, what Internet Explorer, etc. And it can let you know. So it does a very simple job, and you can understand why you wouldn't want to build this yourself. You would just plug in something that does that. Now, because we're all security focused, we're not going to plug any old random dependency into our service. It needs to pass some things. So if we have a look at this, we can see that it has 10 million weekly downloads, so it's obviously very popular. It's got 56 versions, so it's not on version 1. There's obviously maintained history here. And it's got over nearly 2,000, over 1,600 other projects are dependent on this. So this would pass the smell check. At least for me, this would absolutely pass the smell check, and plenty of companies were using this, like Facebook, and plugged this in. Then, a little bit later, this popped up on a messaging forum, which is basically saying, hey, I have an account that I want to sell. It has more than 7 million installations. It has no two-factor authentication, and it's suitable for installing miners and desktops. And they basically wanted $10,000 with bidding steps in 1,000. So I'm sure we can guess what project that was for, and that was selling access, the developer access to Fashal's account on NPM, and very quickly after that, we found some credential scalers and some crypto miners that were injected into that package. They also changed all the credentials on that package so that Fashal didn't have access to it. Now, eventually, after some weeks working with NPM, Fashal managed to get back access to his account, created a clean version. But to this day, there are still people using the dodgy version of that application, or the malicious version of that package. So this is something that we really need to worry about. Tens of millions of people became vulnerable to different attacks because there wasn't two-factor authentication on an account, and an attacker managed to gain access to it. So this is an example of really how quickly our dependencies can be turned against us. And because we're rolling out, because the software supply chain is in the cloud, we're often releasing applications multiple times a week, perhaps multiple times a day. We may pull in the latest version of something without giving it too much thought and roll that out and not realizing that that's malicious. We have another one here, just quickly, quite similar. This one's called Event Stream. Again, passes the smell check, 3 million downloads, 84 versions. But what actually happened in Event Stream was that someone was maintaining it, and then there was part of their job, their project, and then they stopped maintaining it. Well, they started slowing it down. And in walks, what often happens is a good Samaritan from the community, and very often it is actually a good Samaritan, comes in and starts maintaining that project. And someone did that here, where they started actively maintaining that project, and then over time, they became the core maintainer and had access to that. Now, Event Stream was obviously a dependency on many applications, but Event Stream had its own dependencies. And what this new maintainer did was he introduced something called FlatMap Stream that did a simple job. And FlatMap Stream, when it was introduced, wasn't vulnerable, it wasn't malicious, but eventually it wasn't Event Stream that he turned malicious, it was FlatMap Stream, which then in turn turned Event Stream malicious, which made the applications malicious, or at least vulnerable to different attacks. So another example of how we can really attack the dependencies that our application is because of how interconnected, because how everything has moved into the cloud. All right, I won't talk any bit more about dependencies. I want to move on to the next area here, and that's our source, and in particular, kind of our source code. Now, you may think that your source code is developed internally. You may have self-hosted Git repositories that aren't run anywhere else, but I can almost guarantee that your source code is out there in the cloud for people to find, and we'll show some examples of how we can do that too. Source code is absolutely everywhere. Often it's considered, a very high-value asset, but the reality is that source code is very, very leaky. If you're using Git, then immediately your source code is going to be cloned onto multiple developers' machines that are using that. All the developers that have access to that Git repository have access to the source code. It will be backed up into different wikis, which are often hosted in the cloud. It will be shared in documentation. It will be shared on Slack channels. So it really ends up sprawling everywhere. And there's not much we can do about it. And that's the way. And it doesn't necessarily need to be a bad thing, but often because of what's sensitive that's inside source code, it can be. So one of the places I want to talk about is GitHub. And this is what's interesting about GitHub, is that even if you're not using GitHub as an organization, often your developers are, which means that you still have exposure to that. And especially if that source code is then hosted publicly, or even privately but with insufficient security protocols, then absolutely malicious actors can find their way on GitHub. And what's interesting about source code is often there's lots and lots of sensitive information in source code, particularly in the history. If we're using Git, we have to remember that everything we do is maintained in history. So, for example, if you have a developer working on a development branch that accidentally commits a secret, even if they delete that, that secret exists in the source code history. And that's going to be there forever. If that source code finds its way on the cloud, those secrets come with it. So here's some stats around GitHub. Over 1 billion commits were contributed publicly last year. These are stats just for public. 85 million new repositories were created publicly last year, and 94 million developers were using GitHub according to GitHub themselves. So at GitGuardian, which is the company I work for, we tried to do an interesting experiment, and we said, hey, what will we find if we scan every single one of those 1 billion commits and try and find secrets? So we actually did that. For the entire year last year, every single time someone pushed anything publicly, we scanned it for secrets to try and find what we could identify. Anyone here, does anyone here want to take a guess how many secrets we found? 1 million? 100? We found 10 million. 10 million secrets were detected in GitHub. Now, a lot of people will challenge me on this and say, well, how do you know they were real secrets and not test credentials? That's a very good question, but we actually were able to validate most of them. So, for example, if we look at some of the stats on this, we found 2 million cloud provider keys. And those cloud provider keys we validate with the cloud providers themselves. So that was 2 million active keys that we found for cloud providing. Now, so those cloud hosters, what do they host? They host your applications, they host your source code, so all of a sudden those credentials for those are out there as well. So I want to show you exactly how attackers are able to do this. Now, the reason why I'm able to show you how attackers are able to do this is because it's the exact same method that we used to be able to scan this information. So I wouldn't call this a supply chain attack, but it's definitely a supply chain abuse, because this source code, GitHub, is part of the supply chain, but we're not doing anything wrong. We're abusing the way that GitHub works and the resources that they have publicly accessible so that we can try and find malicious information. So we're going to use the GitHub API here. Now this is an API. Anyone can go to this. You don't need any permissions. You go to api.github.com/events, and then you have a ledger of everything that's happening on GitHub. The requests that we're looking for that are interesting are the public events. This is by far the most interesting, because this is when a private repository is turned public, but with it comes all of its history. And then the push event is when code is made. So this is what it looks like here. It's just a ledger. We have interesting information, including, I'll just find some email, including the email addresses of the users here. So here we have the email and the name of that user. Why this is interesting is because if we're wanting to target a specific organization, I'm going to say Twilio, not because I'm picking on Twilio, but just it's literally the first name that came into my head, then we don't need to monitor the billion commits that come through a year. We just need to monitor the commits that are coming from Twilio users and then find out their usernames and scan everything else that they've done. So we can really abuse that. And what I want to do is I want to show you how quickly this can happen of when your source code makes it anywhere public, how quickly an attacker can find it thanks to the cloud. So I have here, very quickly, I'm going to create what I call a honey token. So I have something here, I'm calling it BalCCon demo. I'm going to create this. And here you'll see it gives me some credentials. So these are actually valid AWS cloud credentials. But before you try and take a picture and do some crypto mining, they don't have any permissions. But what is going to happen is if someone tries to use these, I'll get an alert. So I can click in here and I'll see in here if anyone tries to use these credentials. So I'm going to do a cardinal sin. I have a user here called Leaky McGee, and Leaky McGee has very bad development practices, and we have a configuration file here with all kinds of secrets in it, and I'm going to commit this publicly. So now that we've committed these changes publicly, I'm going to come back in a little bit of time here, and I'm going to see if anyone during my presentation has discovered and tried to use these credentials. And hopefully the attackers are on the ball, because it would be very embarrassing if they aren't. But I have a funny feeling that by at least before I'm finished the presentation, people would have found these and used them. So this is really how we have. This is some of the types of secrets that we actually found. So you can see data storage is about 24%. Cloud provider, as I said, was 20%. 2 million credentials we found. Messaging systems. And my favorite is version control platform. That only comes in at 3.8%. But this is basically your private access keys to your GitHub repository that you've put in your public repository. So that seems to happen quite a lot. But lots of interesting information. So because our source code is so regularly available in the cloud, we can actually reliably attack different areas of that. But it's not just intentionally public source code that controls the answer. You can think to yourself, well, we at my organization, we have only private repositories. We have no public repositories, and no one is allowed a GitHub account, okay? But there's lots of times when source code has been, let's say, involuntarily open sourced. So this happened a lot, particularly when Lapsus was being very prevalent. Well, they leaked the source code of companies like Microsoft, NVIDIA, Samsung, and we found out later that the Lapsus was just a group of teenagers, really. And you might think, well, how does a group of teenagers get access to the source code of some of these great companies with great security posture? And the honest answer is that they were mostly just paying for that access. So they were just paying employees to give them access to the source code. Because that's all remotely accessible, then they can then enter into that. If we take a look at one of these, we have the Twitch's source code. This wasn't leaked by Lapsus. This was actually found by someone else, an unknown actor. And this happened because there was a small misconfiguration for a very small period of time, which essentially made Twitch's source code publicly accessible. Their entire source code. There was 6,000 repositories, over 3 million documents. We scanned all of that for secrets, and we found over 6,600 exposed secrets, including 194 AWS credentials. Now, this may seem bad. This is actually really good. If you have this little secrets exposed in a company that big, that's well above typically what we would find in an organization of that size. So it's actually not that bad. But it's still 194 AWS credentials. Now, in this case, the bad actor actually publicly posted Twitch's source code via a torrent. This was the best thing that they could have done, because then Twitch knew that they had a problem. Then Twitch could actually take action of it. Had they wanted to be more malicious, they could have scanned this for secrets and made access into it. So this is another way where attackers are really targeting the source. One other way of, let's call it involuntarily open source, or maybe accidentally open sourced, is that Cyber News did some widespread scanning of domains to try and find exposed .git directories. Basically, trying to find exposed Git repositories, or at least a form of the Git repository that has been accidentally publicly available. And this happens a lot. and they found over 2 million accidentally exposed Git repositories via this method of exposing the .git directory, which is very easily can be used to recreate the Git folder with all the history. So there's lots of places where, because everything is remotely accessible, because it's on the cloud, that we can actually target the source code of these organizations, and in particular try and find sensitive information in them. All right, before I move on to the next one, let's go back to our experiment, and let's see, okay, we already have 2 people from India, 1 person from India, because it's the same IP address, that has found that credential and tried to use it. We can see here that they're using a tool called TruffleHog. This is an open source tool that's designed to find secrets, and we can see this is the call that they've made, get caller identity. So in just a few minutes, in literally 5 or so minutes, someone has been able to monitor the GitHub event, find the credentials, and then use it. Now this isn't someone at their computer in India refreshing the API of GitHub. This is a bot that they're using that's basically finding credentials and checking to see if they're valid with the get caller ID function. It wasn't me. It wasn't me. I'm not. I have a friend in India. Quick, go on. But you can recreate this experiment yourself very easily, and you can test it yourself. It only takes a few minutes for someone to find it, and at the end of the presentation, there'll be a lot more people. And what we'll also find is that initially it will just be these calls to try and get the caller ID, and then we'll get a lot of activity today, maybe a little bit tomorrow, and then it will calm down. And then in 2 weeks, maybe a month, we'll get a lot more activity. And essentially what we've been able to track is that these credentials find their way in public places. They get bundled up with a bunch of other credentials and get sold as a package in some forums, or even given away, and then other threat actors will try and do more malicious things. And that's when you get more interesting events that are happening on them, where they're trying to apply different policies or essentially try and figure out what they can do. All right, so let's now talk about the last area that I'm going to talk about, and that's the build cycle. So our build cycle now has also made their way into the cloud. And I want to give an example of a compromise that's happened in that build cycle. So here we are, we have a tool called CodeCov. CodeCov is actually quite a cool tool, but they did make a fundamental mistake that affected a lot of people. So CodeCov sits in your CI/CD pipeline, continuous integration, continuous deployment. That's essentially the tool that tests your application. What CodeCov did specifically is it tested how much of your application was being tested. So it tested how much coverage you have on your unit tests and everything so that you want to be able to test your whole application. The point of that is it did a very simple job, but it did it well. How you use this application is often you would take the CodeCov Docker image and you'd plug it into your CI/CD pipeline. What ended up happening? On the official Docker image hosted on Docker Hub, which was publicly available to the whole internet, they had hard-coded a credential. This credential gave attackers access to the source code of that application. It was a bash uploader script that was hosted in a Microsoft Drive. And essentially, it allowed them to tamper with it, which allowed them to turn the whole application malicious. They only injected 1 line of malicious code, but that malicious code did something really quite interesting. It said every time you run CodeCov, anytime someone uses CodeCov, and there was 20,000 users that were affected, anytime any one of those users run it, I want you to dump the environment variables, and I want you to send them to me. What that means is I want you to dump all the secrets, all the credentials that you're using to build and test your application, and send them to the attacker. The attacker were really only after one type of credential, which was the private access to source code, the kind of Git tokens. And from there, they were able to make their way into different organizations. Some of the ones that were affected were Twilio, Monday.com, HashiCorp, Rapid7. They all had access. Now, those companies didn't really do anything wrong, but because they were using CodeCov, because CodeCov was part of the build cycle, because it was in the cloud, the attackers then made access into all those different organizations. This was the line of code here on line 525, basically said, send us all your stuff to this address. And this would have been pretty easy to miss. And as I said, this was actually hosted in a storage bucket, Microsoft storage bucket, so it was quite a strange method of how they were deploying it. But yeah, it could easily happen. Now, I almost never pick on companies for having breaches because I really understand that it can happen to anyone, but I'm going to pick on one company just for a minute. I like this company, but there's a company called HashiCorp. HashiCorp creates some great products, and one of the products that they create is something called Vault. HashiCorp Vault is one of the best secrets managers out there available. It does all kinds of cool stuff. Vault is a cool product. HashiCorp is a good company, don't sue me. But HashiCorp created the term secret sprawl. And the whole point of Vault was say, if you use Vault, you don't need to give developers access to your secrets, therefore your secrets will never end up inside your source code, and you won't have a security issue. HashiCorp had to release a security statement to say that because of the CodeCov incident, they had revoked a bunch of private keys because they were exposed inside their source code. If HashiCorp has secrets in their source code, there is no hope for anyone. We also have another example, Circle CI. This wasn't a component in the build. It was kind of like the build process itself. You might be familiar with Circle CI. It has a fairly similar story. Malware was deployed onto a developer's machine. They stole a session ID token. This is actually more powerful than a credential because it bypasses MFA. They then got access to the encrypted secrets that Circle CI customers were using, so they had access to those secrets and they were able to decrypt a lot of them, and then from there they were able to move into different targets. Again, it was actually because there was suspicious activity in Git repositories that this was actually discovered. So there's this three areas of kind of how we can be attacked in the modern software supply chain because of how remotely accessible and how it's all shipped into different areas and how we've really exported trust to this thing called the cloud, which is really just other people storing our data in ways that we don't know. So can we make the software supply chain healthy then? You know, are we doomed in this? Is everything all over? Should we go back to building monoliths in our basement with no internet access? And I'm absolutely not advocating for that. The cloud is here to stay because it provides too much benefits. But there is one fundamental, there's a few things that we can do to harden our cloud to protect ourselves, but the one thing that I want to advocate here today is to stop thinking about outside-in security and start thinking about inside-out security. What this means is to stop thinking about building up defensive walls to try and prevent people from coming into your organizations, and to start thinking about it is that so your supply chain is most likely going to be compromised. It doesn't necessarily mean that you have to be compromised, because it is just the reality of it. Just because someone has access to your source code doesn't mean that all your walls have to crumble. Just because your build's lifecycle was exposed doesn't mean that they have to have access to everything. So if we shift our mindset to inside-out security and we start thinking about what can people do if they make it into our infrastructure, if they make it into our software supply chain, how can we prevent them from moving and how can we prevent them from doing damage? So what can we do as an industry generally? I think a lot of what happens kind of falls back on secrets at some point. At some point doesn't necessarily mean the first step, but secrets are a big point. We should think about moving away from secrets, creating dynamic secrets, using decentralized trust, using different areas so that we rule-based, so that we don't have to rely just on secrets. We need to have a better understanding of the composition that makes up our software. So there's legislation in America that's saying that we're required to have SBOM. This is actually a pretty good start and actually kind of solve the puzzle is what on earth are we vulnerable to? An example is that a company that I know spent 2 weeks after Log4j just coming up with a plan of how to deal with Log4j and not actually kind of making any meaningful process. SBOMs can really help with that. Infrastructure should be default to private. Nothing gripes me more than when the default of something is public or accessible or insecure. It should be hard to make something insecure and easy to make it public. The reason why it's reversed is because organizations want you to be able to start quickly with their product so that you can move and do something before you look at their competitor. Normalize MFA on all these platforms like Git and package managers. This is starting to happen, and a bit more security education. So these are some things as a whole that we can do that would help in the software supply chain. But how can you harden the software supply chain? I'm a huge advocate of honeypots in different ways, in particular honey tokens. That's essentially what I leaked onto GitHub. There's lots of ways to be able to do this. There's GG Canary, which is an open source version. Git Guardian, I work for them, so just know that I'm biased in anything I say about Git Guardian. It has some commercially available tools for that. There's also other honeypots like HoneyPy. Unfortunately, this isn't actively maintained at the moment, but you'll be able to find lots of different honeypots out there. These are a great way to know when your supply chain's been breached, so you can take defensive action, and you can actually start taking back some of that control. Other areas is being able to manage our secrets a lot better. So using dedicated secrets managers. There's tools like Vaults that I've talked about, A-Keyless, 1Password has some tools. There's cloud managers that come usually with cloud providers, so use them. The best tool isn't always the best one for you to use, because a lot of what I see is people using tools like Vault, which are probably too heavy in their application for what you need, which means people don't use them. So consider the different options in password managers, but using them. And obviously scan for secrets. Scanning for secrets is fundamental because it lets you know where your weak points are. Secrets are littered all through our supply chains, they're littered all through our software and all through our applications and our networks. So getting visibility over where our secrets are, because we know that attackers are going to use them. Hardening the supply chain, SCA, software composition analysis, a great tool to actually start understanding what us make up. There's commercial tools out there, Sneak, Checkmarks, Mend. There's a whole bunch of others out there. Everyone has their preference. I don't personally have one. There's open source SCA, like Deep Shield, Dependency Check, and then there's open source tools to help us build SBOMs. So this can really help us actually understand that dependency component of our software as well. Implementing areas of zero trust. So just because someone has a credential to your Git repository doesn't mean you have to give them access to it. You know, zero trust is the concept that you have multiple areas of trust and scope. So something that you have, something that you know, and something that you are. So we can narrow down and we can use these. If one service is only meant to talk to another service, make sure that you can only talk to that service. Segment your environments to limit access. Developers often don't need to have the total control that they do in organizations, but they have often huge amounts of privileged access. So we can segment different environments so that people can't move between them by segmenting out our teams and other areas. And then finally, back to inside-out trust, assume you're going to be breached. So assume that you're going to be breached and that someone's going to breach into you, or a good way to think about it is what could a developer or a trusted employee do if they made it into your environments and they turned malicious. I'm not saying it's going to happen, but that's a good exercise to think about. How could we prevent them? Because that's a good way of preventing someone from coming into the environment. So overall, we're not completely doomed with our supply chain, but we do have to be aware that we're letting marketing teams take away from the fact that we're not always in control of our security. But we can regain some of our control, not by preventing access to it, but quite the opposite, and thinking about what people can do from the inside. So that's the end of my presentation. I hope you enjoyed it, and thanks for watching. And just quickly, these are the requests that we have. So we have some unknown addresses here. We have some from America, India as well. So it wasn't just me that was doing it. It was some other people too. Yeah.
Thank you. Are there any questions? Yes.
Hi. You used SBOM and SCA. Could you explain those abbreviations for someone who's not an expert in the field?
Yep, no problem. So SCA is software composition analysis, and the software is the SBOM is software build of materials, or
Bill of materials.
Bill of materials, yeah. And so basically, SCA is essentially looking at the composition and dependencies that your software is built up of, and it checks them against a database of known exploitations. And it will let you know if you have any vulnerabilities based on the dependencies and the versions that they have. So it's a very quick way of knowing if you have critical vulnerabilities that have been introduced by your dependencies. Now, unfortunately, the way that SCA works at the moment is that a security researcher, and thanks to a lot of these companies, they actually sponsor a lot of these security researchers, but they have to have found the vulnerability and reported it. So it's not real-time effective. but it's much faster than what you'd know if you weren't using it. And the software bill of materials is really creating a list of all the different components that your software is made up of. And why that's so important is going back to the Log4j reason, is that as a vendor, we had a lot of customers using our tools that were calling us that were trying to figure out if we had any vulnerabilities with Log4j. Are we affected by this in any way? And we then had to go to all of our vendors and all of our dependencies and ask them, are you affected in Log4j in any way? And then they had to go on, and anyway, this is why it took such a long time to even understand if we're vulnerable. Having a software bill of materials is essentially a ledger of what your software is made up of that can be publicly available and easy to share so that people can actually immediately know. There's very rudimentary versions of that, and they're starting to get some very complex and flash ones, including ledgers online, ledgers that compile, that can create automatic graphs of kind of what you're vulnerable to in different areas. But it's a great way of visualizing this. And by making it mandatory in the United States, it's really meant that this has become a standard that everyone should have. So when we face the next Log4j or Log4Shell, then we will at least probably have better visibility. Hopefully that answered the...
Thank you very much. Yes, it did. Second question, if no one else? You showed the scheme of Salsa and all the points where someone could be vulnerable, and then you iterated several times, and the most recent Microsoft breach showed it again, that developers are one of the main problems / targets / whatever. Shouldn't they be highlighted in red and maintained somehow differently or managed somehow differently? And second to that, you also mentioned training and awareness, etc., which would bring in the whole level of management as another obstacle to get more secure code, because they have to sign off, they have to pay for it, they have to be aware. So the human factor, you mentioned it in your presentation, but it wasn't on the Salsa slide. So,
right. Yes. Well, I mean, the human factor is kind of in everything, and kind of everywhere that it is. Like the developer component, I guess, on my Salsa slide was the attached to the source. But of course, the developer is very vulnerable, and they're high-value targets for attackers because they have such privileged access, but they don't always need such privileged access. The reason why they have such privileged access is because it is a way to kind of, for an organization to move quickly without enforcing lots of different policies, which can be seen as a roadblock. There's been some great presentations that I've gone to that talk about why this is totally false and how good security actually increases productivity and speed. But it is still a common misconception, especially in startups, that by limiting your developers' security, you're going to limit productivity. And like this common example of this, giving developers admin keys, because then they can do lots of things with one set of keys and you don't have to manage more of them, instead of actually making them use a secrets manager to retrieve the correct key for that situation in different areas. And the other area, I don't think, where developer education really comes into this too, is the fact that developers often don't know why they're being limited. They don't understand, like, why can I not have an admin key? I'm not going to do anything stupid. I've been working for 5 years in this field. Now, research and history shows that we will all do something stupid, myself included. So we need to protect ourselves from ourselves. And by educating people on why we need to do this, it's a good way of really helping them understand the roadblocks that are in place and will ultimately make us move faster.
Thank you.
Hello, thanks for the presentation, first of all. You mentioned that your scan revealed a lot of entries and you highlighted the results in categories. I was a bit curious. Did you ever come across any significant abnormalities in provider representation within those categories? For example, was DigitalOcean overrepresented in revealed cloud keys?
So we haven't, the biggest abnormality that we saw, which wasn't in the slides, was actually in November and December. We had like some ridiculous 12,000% increase in OpenAI keys that were released. This is kind of coincides with the popularity of when ChatGPT came out and areas. So we did see some abnormalities in that. A good abnormality that we actually are seeing now in new research is the number of AWS credentials that are leaking is dramatically dropping in comparison to other cloud providers. The reason why is AWS is actually taking quite seriously the shared security model that they have, and they're also actively looking for leaked credentials and blocking them and alerting people when they've leaked them. So we're starting to see this series. We're hoping that we're going to see much more of this, and it will be the abnormalities in the future will hopefully be the companies that aren't leaking the most, the companies that are leaking the most amount of keys are the ones that aren't actively on this journey. So they're starting to see some good things that are happening. So there are a couple of the abnormalities that we saw. There wasn't anything that stood out, and I think that comes to the volume of the data is so big that it encompasses it. But for example, there was some new cloud providers that were coming out. I'm trying to think of their names, but I can't at the moment. But you could actually see how popular they were based on the number of keys that were leaking throughout the year. So you could kind of see their growth by how many keys were leaking, which we thought was quite funny. But definitely some outliers in there, and definitely some good stuff happening, which is going to interest. We're doing the study again this year, and my personal belief, based on what I've seen, is that for the last 3 years we've gone up. I think this year is the first year we're going to go down in the number of secrets that are leaked. At least that's what I'm hoping. So we'll see.
Awesome. Any more questions? Maybe one more quick question. Okay, no, nothing. Thank you.